This is the third in a series of short videos on computational physics. In this video I'm going to demonstrate the use of MATLAB to do some more sophisticated calculations that may be useful in computational physics. As before, I've got the MATLAB window and available here with the commander window selected, and I'm going to now enter in some x values. So I'm going to enter in an array using our array entry notation. That's the square bracket. I'm going to do 1 space 2 space 3 4 5 6 7 8 9 10 and hit the close bracket, and I've created an array of x values. One of the nice things about MATLAB is because of this iterable function ability, I can do quite sophisticated things with very relatively simple commands. Say I want to square each and every one of those x values. I can do that by entering in x dot power 2. Remembering that the dot notation is needed in order to do an element by element application of that power function. So if I enter that in, I get a set of values out. Now of course, what I'd like to do now is I'd like to enter those in as an array of y values. So I'll do y equals x dot power 2, and I've now created an array of y values to go with the array of x values. Because they're of the same length, I can plot them. So let's do that. Now in MATLAB, like in many other programming languages, some of the commands won't have obvious names and you may need to hunt for them. But in the case of the straightforward two-dimensional plot function, the plot function is just called plot, and I can check that by typing help plot. I hit return, and there is some help text, and if I scroll to the top of it, you can see there's lots and lots of options, including doing things like selecting colors and solid lines and things like that. But the basic syntax is always given right at the top, and you can see that one syntax I can have is to use an array of x values, an array of y values, and we'll plot y against x. So it so happens I've already defined some x and y values. On the right hand side you can see them, and they have the same length of course because y was derived from the x values. So I can just do plot x comma y, and I hit return and a plot window appears, and you can see I have a line, and if you look closely you can see where the individual points are, every integer value of x. I'm going to move that plot window over to the right, and I'm going to shrink the main IDE window so that I can see both at the same time. Now remember that I can access the previous command simply by hitting the up arrow key. So I'll do that, and that allows me to go back, and I'm now going to enter in one more option. I'm going to type quote r quote. So this is an option for the plot command. And if I do that, you can see the effect it has. It's replaced the previous plot window. Actually, it's completely redrawn it, although that isn't immediately apparent in front of us here. But you can see that it's replaced the original default color, which happened to be blue, with a red line. That's what the R means. And I can change that to a green line, should I desire, by hitting G. Let's say I wanted black. Well, of course, blue is already taken. That's B. So in order to get black, I can't use the letter B, I can have to use another letter, and borrowing from the language of graphic design, that letter is K for key. And I can do a line in black. Let's say I don't want to just have a line, let's say I want to have some individual markers. Let's type a plus instead, and now I get blue crosses, blue being the default color, I get little blue crosses. If instead I put a little 0, a little O actually, then I get little circles. And I can combine those with a line. I can ask for the line again, and by doing a dash, and I'll get a line and circles. And of course I can now add the color on top as well by adding the R. And you can see each time I recall that command, I just hit the up arrow key and I can change the previously entered command. This is much quicker than typing it manually each time. If I put a colon in, I get some dots. So that's rather nice. So I can very quickly generate some x values and some y values, and I can plot them. So for example, if you're doing laboratory work, you can enter those x values and calculate some x and y values, and you can plot experimental data just as well as you can calculate y as a function of x. Let's say I've got a large number of x values that I want to enter, and I don't want to enter those values manually by doing this, entering x equals 1, 2, 3, 4, and so on. Is there a quick way of doing it? Well, of course there is, because MATLAB is quite a nice programming language. I can use the colon notation. If I enter 1 colon 100 and hit close bracket, then I can get 100 values from 1 to 100. So if I scroll up, you can see that I've very quickly generated 100 numbers. If I hit the up arrow key and go to 1000, I can go to 1000 very, very easily. And if I now do y equals x to the power of 2, I can now generate 1000 values of y. And if I scroll through the previous commands, I can now replot x and y with all those new 1000 values of x and the corresponding 1000 values of y, and I've now generated a very large number of them. And you can see that because I've got so many x values now, I probably don't want to show each individual point, so I can turn that off by getting rid of the little O, and let's just have a line again, and you can see I now have a nice smooth curve. Let's say I want to plot some values which aren't integers. Can I do that? Well, let's go back to my definition of the x values. Let's try that 1 to 100. And instead of entering in 1 colon 100, which gives me an integer spacing between the x values, I can put something else. Let's try putting a 2 in between. So let's see what that does. So I have an extra colon. So it's going from 1 to 100 in steps of 2. You can see that the first value is 1, the next value is 3, the next value is 5, and so on. And you can see that it doesn't give me the final value 100, it goes up in steps of 2 until it gets beyond the last value. So it doesn't necessarily give me the final value I've asked for. It steps up in the step size that I've chosen and then stops when it goes beyond the boundary that I've selected, which is 100 in this case. Let's try another step size, a slightly smaller one. Let's try 0.1. And if I hit return, you can see I've generated a large number of values, this time spaced in spacings of 0.1. Now, of course, I don't necessarily want to show each and every one of these numbers whenever I've generated them. I can stop displaying all those numbers by putting a semicolon at the end, on the end of my command. And that will define the array, but it won't display the answer. So that semicolon notation will be very useful later on when we come to use scripts. So I've now generated some x values. Let's generate something else. Let's generate some y values. Instead of generating the square, I'm now going to generate the sine of x. And as you can see, it's a very simple notation. Rather than thinking of x as a single value, x is an array, and when the sine function operates on x, it operates on each and every value of x. Now, I don't need the dot notation here because the sine function can only iterate over a single array. It'll operate on each and every value of x, no matter in what form x has. So I can now generate those values of y, and here they are, a large number of them. And now if I do plot of x and y, remembering to enter R because I like red, I now generate a sine function, which you can see on the figure on the right hand side. And you can see quite clearly now that it's overwritten the previous window. So that's how we can do simple data plotting. In the next video, we'll do some more sophisticated examples.